So hello everybody. Thanks for joining my session. It's about a journey to microservices of an application we built. So my name is Timo Stark. I'm web developer and cloud solution architect for Audi. And what we are talking about today is this diagram, not the whole diagram, just the part on the very left. So the Audi Cockpit, what is it about? The Audi Cockpit is an internal microservice-based web platform we built on AWS and Kubernetes. And that's because as an Audi employee, you need to handle a lot of different information during your workday. I think this is an usual problem. You're working in some business and have multiple systems exchange for your emails, calendar entries, and a lot of other systems providing you with necessary information. And you need to log into all of these different systems and get the information you want at the point you want, at the time you need. And this was some problem we had. And that was the reason why we created the project of the Audi Cockpit to build a dashboard platform where all of these information are centralized per user. So I am a user of that platform. What I have is like virtual desktops, and I can arrange widgets and functions in the way I want and can make information transparent for my daily business. I think the best thing to describe what is the Audi Cockpit is the main core functionalities is like an iOS device or a smartphone in general. If you buy a smartphone, it's like you have some basic widgets or apps installed like calendar, SMS, phone, all that stuff, and exactly what's with the cockpit working as well. You have the Audi Cockpit and some basic core functionalities, but who in this audience installed so no apps on its smartphone, just use it out of the box? Nobody. So that's exactly what's, and the idea behind the Audi Cockpit is quite the same. We have a platform, and the functionalities or the main functionalities comes with widgets and apps provided by some other internal departments to the Audi Cockpit. That means the more functionalities we have, or the more widgets we have, the more functionality we have. And this is a critical aspect for scaling, because the more functionalities you have in that cockpit, the more use cases you can serve or you have, the more traffic you have. And that's why we are choosing and Kubernetes as an orchestration platform and NGINX Plus as a load balancer, API gateway, reverse proxy in front. So one interesting thing here is that we use API gateway or the NGINX Plus API gateway in front of our ingress controllers. This is something unusual. I saw a lot of diagrams put NGINX Plus as an ingress controller and use the functionalities of API gateway and reverse proxying and load balancing as an ingress controller. But I will go in detail right now in my session why we used API gateway and NGINX Plus in front of our ingress controller. So first of all, we are doing a deep dive into the different host names I provided here and what is the configuration on NGINX. So first you have https yourhost.com, which is the main front-end application. The front-end is built on React.js and is hosted inside Kubernetes as a pod as all the other microservices as well. So this is nothing special. The special thing for yourhost.com is that NGINX is configured to protect that host name or the resources behind that host name with OpenID Connect and the authorization code grant. I will go in detail what is the authorization code grant and OpenID Connect in the next slide. The other host name is API yourhost.com, and this is our main API host. And there's kind of different because the API yourhost.com is protected with OpenID Connect, but not with the authorization code grant, but with the Barra header. That means we have a different configuration on the NGINX instance for yourhost.com and API yourhost.com. And the third one is a mobile API gateway. As you can see in the down left, there are two different things connected to NGINX Plus. The first one is the Keycloak IDP, handling the OpenID Connect authorization code grant and stuff like this. And the other is an API gateway of CA Technologies. And the problem is that the CA API gateway in our installation can't handle OpenID Connect for a mobile. But we have at Audi internal, like an iOS framework, handling client certificates on your iOS device to make an authentication. So the only way of communicate with our infrastructure is through the CA API gateway. And the problem is the first two hosts, the your host and the API your host, is connected with OpenID Connect and is configured to handle OpenID Connect things. And the third one, the last one, is completely different. This is CA Technologies. It's not based on OpenID Connect. It's based on a token exchange. So that means the CA API gateway is validating a user based on the client certificate on your iOS device, and is generating some session identifier. It's like a token. And this token is sent to our API gateway, to the NGINX Plus, from the mobile app. And what we need to do is we need to send this particular token back to a CA API endpoint and verify if this token is valid or not. And based on the response code of the CA API gateway, which is a 200 if the token is correct, or in 403 if the token is not correct, we can redirect the user to the service in the cluster. And the challenge here is that you can imagine the service inside Kubernetes, that means on the right side, is not the right part of dividing between, okay, this is a user from the mobile app, or this is a user from a desktop app, or this is a service-service communication with another API. The backend services, the APIs on the right side, need to be like stable. They handle each request in the same way, nevertheless where they come from. So that means the intelligent is here inside the NGINX API gateway of creating header field, creating new tokens, creating a structure our APIs in the backend can understand, nevertheless where the user comes from. If it's a mobile API, or if it's a service-service communication, or it's working inside JavaScript from our front-end React.js application. Something interesting are the links on the bottom of the slide. The left one is the OpenID Connect integration of NGINX Plus. It's a good GitHub repository where you can find all the configuration files you need. And one of them is in standard for OpenID Connect, but there's a nice slide with all these standards listed. Well, how many of you are in charge or know the OpenID Connect OAuth standards, how they come together? Okay, perfect. So not all of you, that's good. Something you need to consider, you should know about, is that OpenID Connect and OAuth are not the same. They're different things, and they're most of the time put together. You have the OAuth 2.0 core, it's in the red corner, the Barra specification, the core specification, the JSON Web Token profiles, and all that things. And the OpenID Connect protocol suite is like a framework, or it's a protocol suite on top of the OAuth 2.0 protocol. This is very, very important. So this is, if you're really thinking about using OpenID Connect and OAuth with your NGINX Plus instances, you should consider this picture. That OAuth and OpenID Connect are things comes together, but it's not the same. They are complete different things. And there's a link down there. You can visit the OpenID Connect page and get more details about that stuff. On that link, you will see that picture, and then you can click just on core or discovery, and then you will be redirected into these specific specifications. So what is a JSON Web Token? The RFC 7519 is the official standard for JSON Web Tokens. A JSON Web Token is more or less not more than just an base64 decoded string I can send in the header, and it contains of 3 different parts separated by a dot. It's the header, a payload, and a signature. This is an example of it. Another important website is Jot.io, where you can find general information about JSON Web Token. And this is a little website, a tool on that site. You can just paste the base64 encoded string out of your barra header, for example, and they will do the encoding for you. So this is on the left side, the base64, and on the right side, the decoded string. So what you can see here is the red one is the header, the purple thing, the signature, and the lightly blue one is the signature. And it's divided by dots. And so on the left side, the registered claim names are important because this is kind of reserved names. In the payload section, so where you can see subname, admin, whatever, you can put just whatever you want. But just keep in mind, if you put information in the payload, physically, the token grows. And sending huge tokens over the network, like 128K or 256K, whatever, is not the best idea. So you can put the necessary information, let's say this, you can put all information you want or you really need inside the payload section, but just keep in mind, keep the token as small as it should be. Smaller tokens are easier to handle. So the payload section, you can put information in it. The header section, I have another slide of an important fact about the header thing. And the signature is an hash value because a JSON Web Token can handle it on two different ways. The first thing is you can have a JSON Web Token validated by a signature, or you can handle or can work with unsigned JSON Web Tokens, and this is never a good idea. Because the JSON Web Token is sent over HTTPS in the header, and it's just base64. This is not an encryption. You can encrypt tokens, but this is not a session about JSON Web Token in general, so I will not dive into this topic. But the signature helps you to trust that the token is not manipulated on the way of the IDP sends to the NGINX, and it's so NGINX can verify the signature based on the key and can check if the token was modified or not. So if you're using tokens, make sure that you are not allowing untrusted or unsigned JSON Web Tokens. One important thing here is this is based on a problem I had on my infrastructure because it's missing on that slide. You have a key ID, this kit thing, and this is the IDP will create a JSON Web Token and create the signature out of a JSON Web Key. It's like private and public key. The public key is something you can download and need to integrate in NGINX. I will show you this in a configuration example right now. And the key ID is something you can find in the JSON Web Token. And the key, which is inside of NGINX, has the same key, or should have the same key. I had a problem in my infrastructure that I configured the wrong realm on our IDP. So the login is working, but the problem is that the key which signed the JSON Web Token was a different one from that key I imported to my instance, and this will not work. So and that's why this key ID is something you should know about. This is not just kid and then random string, so this is pretty important. If you have some trouble with authenticating or validating a JSON Web Token on your NGINX instances, make sure the key ID of the imported key on your instance is the same as the key in your received JSON Web Token. That's why I'm pointing this, because it was a pain for a personal perspective. So these are the standards for Auth 2.0 and OpenID Connect. There's something you can read. So I think all of you know the IETF pages. It's like text as an HTML page, so it's not fancy, but a lot of useful information. So let's go into some configuration. So this is the configuration downloaded from the GitHub repository of NGINX Inc. With some lightly modifications. But in general, what you see here is the JS include things is based on the NGINX and so the engine script module, which is pretty awesome. I really like it. I use it for a lot of other use cases right now. So what you can see here is a normal server configuration. We have listen4 for 3 SSL, certificates, and these are my configuration items for, you can see the JSON Web Key. This is the file, the public key file of the IDP, and in the new release, I think, or in one of the other releases, this is something which can be downloaded from a host directly. Then you have the auth endpoint and the token endpoint. These are some URLs from your IDP. It depends on what IDP you're using. Client ID and secret. It's like this is for the trust relation between your NGINX and the IDP. And then you have the token type of what token you will receive from the IDP, an access token or ID token. And then you have the HMAC key. So this is something other important. If your tokens are very huge, or if you send a lot of data inside your tokens, like authorization groups or stuff like that, your token will be will exceed the 8K limit of NGINX in default. So that's why you can set here the sub-request output buffer size to something like 64K to make that working. So then you have here an include of the OpenID Connect server config, which is here some cookie things. This is the auth endpoint. This is an interesting thing because this represents here the authorization code grant. That means if you're not logged into the NGINX or to the IDP and there is no cookie present, the NGINX Plus will redirect you with a browser redirect to the login page of the IDP. And you can log in with username and password or client certificate or RSA secure ID, whatever. But this is important. You build your login page on the IDP side, not in your application. This is something which is not part of your application anymore. So this is the redirect. So this is the token exchange, which is this is the technical implementation of the authorization code grant. This is like you're redirected to the IDP, successfully logged in, and the IDP will send an authorization code back to the NGINX instance. And what we are doing here is we're using that authorization code grant and using an internal request to ask the IDP again and send the authorization code with this request and receive an access and refresh token and ID token from the IDP if the authorization code is valid. If not, you will have that's on 403, I think. So this is the authorization code grant. This is important because the API.yourhost.com configuration is pretty much, it's not the same, it's very easy. It's just 2 lines of configuration, but I will go into this. So this is the token endpoint. As you can see here, this internal statement, that means that just NGINX can call this endpoint. If you're trying to call, I don't know, your public IP address or hostname /_token, you will not be able to access this location because it's internal. So this is the code exchange endpoint. It means we're sending the authorization code back to the IDP and receive an access and ID token and refresh token from that IDP. So this is the configuration for yourhost.com, the authorization code grant. For the API, believe it or not, it's just this. I just say auth.jot is Audi Cockpit API, for example, and then I say this is the key file, and with this configuration, I'm telling NGINX Plus that I expect a bearer header with a valid JSON web token as a base64 encoded string as a bearer header. If the bearer header is not present, you will not be redirected to the backend. So that's it. So that's all the configuration I need for api.yourhost.com. Because for an API, and I have another challenge I can show you. If I'm a service to communication, let's make this example. I'm on Java API and I want to do a web request to one of our APIs behind that API gateway. So what I can do is I can call the IDP, which is not part of my application, but I can call the IDP with a grant type password, for example, and give my username and password for my technical API user and receive an access token from the IDP. And then I can just send this access token as a bearer header to my api.yourhost.com, and that's it. So in the NGINX Plus instance, we'll see the bearer header, we'll check the signature, and then if there's no other configuration needed, so this is just the basic one. If you want to check some ACLs or role-based access control and do some other stuff, this should extend your configuration, but this is just the basic thing. With these 2 lines of configuration, your endpoint is protected with the OpenID Connect or with the bearer header. So nobody can access a location behind, so nothing in that location without sending in bearer header and valid bearer header. There is another example which was useful for us. You can set some proxy headers, and these proxy headers are attached to the request to the backend and not present for the front end. So it means so if I call this API endpoint, I can't see these header parameters. It's just something internally. And that helps if you say you have, as I mentioned here, you have 3 different types of, you have the front end thing, you have an API with this part of OpenID Connect, and you have something completely different, which is token based or whatever. So with this mechanism, you can say, okay, I set an authenticated username and a username in plain text or an email address or anything as a header parameter and send it to my backend. So and my microservice is listening for, let's say, these header values and accept an authenticated user based just on these header variables. Or you can recreate some tokens or whatever it is possible. So but with this 4 lines of code, you can protect your API host and make it secure for requests from the internet. Well, let's see. So this is more about the NGINX JavaScript module, which is really worth take a look on it. And this is something we missed at the point we started. I call it like a macro design for APIs because we started creating APIs, creating Kubernetes ingress rules and NGINX configuration without having a real plan or like a blueprint of how we want to build our APIs. And then you're at a specific point where you will have trouble routing your API requests to a specific service. And that was the point where we decided we need a macro design for our APIs. It's like the policy says HTTPS all the time. From the beginning till the end inside the cluster, anything is protected with TLS encryption during transport. Then you have the host name, and we saw in the example, the host name is not a critical part. But the critical part is the context, which is here the definition, like API v1 activities. And then you have activity, like page offset of 25. So that means that API v1 activities is the critical part because this routes the traffic to the right service. So we use Kubernetes for hosting our microservices or our containers. And this definition here, you can see on the middle, is something what we deploy together with our microservices inside Kubernetes. So the definition part is something our developers can define and can deploy automatically to our cluster. So that means the configuration, as you saw in the class and the API gateway, is just listening to API yourhost.com and protect it with an OpenID Connect bearer header. And then route the traffic to one of our Kubernetes workers. And inside Kubernetes, I have these request mapping API v1 activities. And based on this context, the Kubernetes ingress controller knows which service is in charge right now for that request. So and that's why this is something you should really do at first. Make yourself in mind, what is the API macro design? What's the actual plan of creating APIs? What is the naming conventions? Because after that, it's like straightforward. All the configuration items are the same. There's an ingress controller. Let's see this. So this is like, you have here your API yourhost.com. And this is the path configuration, as we saw, API v1 tokens or API v2 tokens. And this is service name token service. And this is an old configuration because this is port 80. Right now we are using port 443. So we haven't fully encrypted pipeline or traffic route from the API gateway. There's the first TLS handshake on NGINX API gateway. The second one is the ingress controller of Kubernetes, and the third one is inside the microservice based on Spring Boot itself. So we have TLS all over the way to the service. So, but this is a good example of how that works. So you specify a host name here, API or mobile API, yourhost.com. Then you specify the path, which is the context, it's the middle thing. And anything which is after or comes after the path, token equals question mark 25, whatever, this is part of your API itself. So as you can see here, this is a Spring Boot example. You can see the endpoint is API v1 tokens. This is the context thing. And then you have the post request mapping to /token/ whatever. So we are talking about RESTful APIs. Missed to say that. All of these APIs are RESTful APIs, no RPC or anything else. So there you can see this is a service I built for handling these refresh token things and access token things from a single page application. And we have enough time that I can show you this. Be aware, some parts, they're critical. The sub-request output buffer size. Keep in mind, if your token are too big, you need to increase that value to make it work. Otherwise, the token can't be transferred from the IDP to your NGINX instance. And another important thing, I missed that at the beginning and was interesting to find that. Somebody heard of SNI? Liam, always. So this is the server name indication. So, and that means because we are running all of our traffic route on HTTPS, without SNI, Kubernetes can't see the host name in the request. And as we saw now in my example, the request routing in Kubernetes in the ingress rule is host-based. So that means I need the host first, and then I can take a look at the context and route the traffic to the service. Without SNI and HTTPS in place, this will not work because Kubernetes or the ingress controller in general can't see the host name in your request. So that's why you definitely need to configure the SNI thing in the HA proxy or in the NGINX ingress controller. It's enabled by default, I think. The only thing you need to know is that you need a certificate in your ingress definition to make the SNI thing working. So it's not enough to say my ingress controller can handle requests based on HTTPS. You need to specify a TLS certificate inside you have your ingress definitions, and this is this part. So you specify in secret, and then configure TLS host is API yourhost.com, and then TLS cockpit dev jar jobbings, whatever. So that's enough to make the SNI thing working, because then you have a certificate, can do the handshakes, and then SNI is configured. So then you can see with SNI in the client hello at the handshake, the API yourhost is as clear text present. And without, it's just client hello without host name. Yes, in the last 7 minutes. The token service. This is something important because we have a single page application based on React.js, and the access tokens from our IDP we have in a cookie, so that means we can send it anytime with a request because we have it in a cookie, but the problem is that the lifetime of an access token is just 5 minutes. So that means we have an access token, 5 minutes, and the refresh token with a lifetime, in that case, of 12 hours. So, but it's never a good idea storing a refresh token client-side, because a refresh token grants you the possibility of requesting new access tokens just based on the request token or the refresh token. So that means with a refresh token, you can recreate as many access tokens you want for the period that refresh token is valid. So this is like storing username and password in clear text client-side in a cookie. You will never do this, right? So we will not do this with the refresh token either. So we have a problem. The single page application is based on React, and you will not reload the page any 5 minutes. So you will stay stable, not reloading the page, but doing API calls anyway. So what I did is I used the different functionalities of NGINX Plus and a little microservice based on Spring Boot, doing the following. The user is logged in to the yourhost.com based on the authorization code grant, and NGINX is doing an internal sub request from inside this JavaScript engine script module, and is sending the refresh token of the user to an internal microservice in our backend hosted in Kubernetes, and is creating a JSON web token session identifier, and set this x.session string as an HTTPS only cookie inside your browser, so you can't modify it from the browser side. So what I have right now is I have a session token or cookie set in my browser, not the refresh token, but an HTTP only cookie. And I have a backend service knowing this string and a refresh token. And this is something, this line here is configured that only NGINX can call this post request, or can just make this post request, nobody else. And from the front end, from the API perspective, if you want to make an API call from the front end, you're calling the token endpoint first, and I will send the x.session header together with that request to the API gateway, and then redirect or route the traffic to the microservice in the backend. The microservice here, down here, the token service, is doing all the refresh grant type, the interchange with the identity provider, and send an access token back as a response to that request. And then the JavaScript can just use this access token, this is already base64 encoded, put it in the barra header here, and do the API request out the front end and get through my API gateway to the backend. So this is already pen tested and talked with our security, and this is like state of approved. So this works. So that helps us to store the refresh token securely in our backend and not giving it to some client-side cookie or whatever. Another important thing here is that our front-end developers want a username, email address, whatever, accessible from the client side, just to put it in like, hello, you're logged in, and that's your name. So that's why I used NGINX, reading the access token, decrypt it, and put the username, the surname, first name, email address, and all that stuff out of the token, create a new one, and set it as a browser or JavaScript accessible cookie. This is the green one. So with this cookie, this is not critical, because this is just a username, and all that rights and authorization is based on the access token you can't really modify. So this is not critical, but helps our JavaScript front-end developers to see, okay, this is the logged in user, that's the name, and can just put it into hello, you're logged in, Timo Stark, for example. So this is another good reference from Auth0, not to store and refresh token because it's sensitive data in the front end. Don't mind if it's the local storage or if it's a cookie, never store a refresh token client side, never, nowhere. Not in the local storage and not in a cookie, or in a text file, or somewhere else. Okay, 2 minutes. Another cool thing here on NGINX Plus is the ASG Sync. So this little tool can watch our auto-scaling groups on AWS and configure the upstream service in our configuration dynamically. So that means before I used the ASG Sync tool, I had an NLB in place on AWS watching my auto-scaling groups, and NGINX is sending the request to the NLB, and the NLB knows which members they have in the auto-scaling group, and then route the traffic to one of the Kubernetes workers. With this, I do not need the NLB or all the other stuff. I just say NGINX configuration here. This is my auto-scaling group, port 443 HTTP. Sync is 5 seconds, and then NGINX will do this for me and configure or reconfigure the upstream part dynamically. So that means I can watch my auto-scaling group without reconfiguring, restarting my instance. This is on here. So this is basically how that works. And then you have here the configuration. So you specify here the backend one conf, and this is where the tool writes. It's just, and so this config file looks like a typical upstream configuration: server port, server port, server port, and this is dynamic based on the sync interval on your of the members of the autoscaling group. Any questions? At this point, are we good in time? Thank you.